is section 4 of chapter 1 of geometry. Our topic today is measuring angles. The objective for today is to find and compare the measure of angles. So, if we look first at this first problem, which angles below, if any, are the same side as the angle to the right? So here is our angle that we're dealing with. And we need to determine which angles are the same. So there's a few ways we can do it. One, we can just kind of look, and we can eliminate some. Like this angle G, that's too big. This angle A, that looks too small. This angle B looks too big to me. And so these other four, they'll look like they could be the same. And if we wanted to then verify our answer, we can actually take out a protractor and measure these angles and determine if they are the same measure. And so something we need to make sure you get a chance today is that you can use also number operations to find and compare the measure of angles. And so here we have some definitions for today. An angle is formed by two rays with the same endpoint. The rays are the sides of the angle. The endpoint is the vertex of the angle. And so if we go over to our drawing, our diagram, we have this angle, and we can name it a few ways. We can name it by its vertex, angle A. We can name it by the rays and the vertex, so we can call it BAC. We could also call it CAB, and those are different. Our last name we could call this angle 1 by a number as well. And so when naming an angle, if we're going to name it by the point on each ray and the vertex, we need to make sure that the vertex is in the middle. So when we name that first angle, it's only appropriate to name it angle BAC or angle CAB. Calling it angle ABC is referring to something else with B being the vertex, so that would not work. So when we're talking about angles, we talk about some different spaces in the angles. We talk about the interior of our angle, and that's the inside. That's the space in here. And then we also talk about the exterior of our angle, which is all the points that are on the outside, the region that's on the outside, and that's all this space out here. All right. And so here we have some different angles. And so what are two names for angle 1? Well, if we're going to name angle 1, we see that angle 1 is right here. And so if we trace that angle, it goes like this. So two names that we could give it, we could call it angle JMK and angle KMJ. And both of those names would be appropriate. So what I'd like you to do now is pause the video and answer this next question. Question 1 down in the got it section. Check your answers with mine. I said that for number 1A. Two other names are angle 2 or angle LMK. And this last question is a really good question to ask yourself. It says, would it be correct to name any of the angles angle M? And I say no. Because if you're looking at angle M, well, that's where these two different angles meet. And so it really looks like it's the vertex of angle JML or LMJ. And so if you were trying to call angle JMK angle M, I think you'd be referencing a larger angle than you're actually attempting to. So it's a no. One way to measure angles is in degrees, and so I've mentioned that earlier. When we want to indicate the measure of an angle, we place a lowercase m in front of the angle symbol, and so we say for this angle A, we say m, which stands for measure of angle A, is 62 degrees. Okay, and we are only going to use degrees to measure angles. There are some other measurements we can use, but we're going to stick with degrees. So something to keep in mind is a circle. A circle has 360 degrees, so 1 degree is 1/360th of a circle. A protractor forms half a circle and measures the angles from 0 to 80 degrees. So we're going to do some work with protractors over the next few lessons. And if you look at this postulate, consider the ray OB and point A on one side of OB. Every ray of the form OA can be paired to 1-to-1 with a real number from 0 to 180. So what they're really saying is that if we start with this nice radius right here of a circle, we can then measure out to say we had another point here. We could then draw another ray out to that point, and we can measure how many degrees that is. And that would be a 65-degree angle. And if we're looking at this bigger angle, AOB, well, we follow out that ray. That ray goes out to about 125, so we would say that's 125 degrees. And so your protractor is going to look a little bit different than mine. This is mine that I'm going to be using. I can drag stuff, I can turn it, I can measure stuff out, I can make it a full circle. So the protractor postulate allows you to find the measurement angle. So if we consider the measure of angle COD below, it works the same way as our as when we were finding the difference with our ruler postulate. This angle is not lined up with this nice line here that we had before. Instead, we have a ray C and we have a ray D. And so if we measure how many degrees of that ray C is at, and that looks like it's about 135 degrees. The absolute value of 135 minus, well, that D looks like it's at about 32. We subtract those two and take the absolute value. It leaves me with an absolute value of 103. That would be the measure of our angle. So we would say that the measure of angle COD equals 103 degrees. And like I said before, remember that this is very similar to the ruler postulate we talked about before. So when we label angles according to their measure, it is called classifying. And so we have 4 different types we can talk about. We have acute angles, and I always think of acute as, oh, look, cute things are so little. And these are the smallest angles we're going to be dealing with, from 0 to 90 degrees. And then we have right angles, and these are 90 degrees. These are like when you see a corner. We have obtuse angles, and these are big angles. They're between 90 and 180 degrees. And then we have straight angles, which are exactly 180 degrees. And the way I remember straight angles is I think of a straight line. A straight line is 180 degrees. A straight angle is 180 degrees. And if you look at that symbol, that corner symbol up here in the right angle, that indicates the right angle. So if you ever see that, they're giving you the angle measure. They're telling you it's 90 degrees. And so here we have some different angles, and so we're going to measure and classify them. What are the measures of angle LKN, JKL, and JKM? So let's write that down. LKN, JKL, and JKN. And so first, it helps to know where all of these angles are. So it looks like L is at, we're going to say it's at 145 degrees. Looks like J is at 90 degrees. N looks to be at 30, or M is at 35 degrees. N is at 0 degrees. So if we're finding angle LKN, here's LKN. Well, if we start from 0 to 145, we would say the measure of angle LKN equals 145 degrees. So now we try another one. J is right up top. So here's J, we go to K, and then we go to L. Well, this is where we need to use that distance postulate. And so we take, okay, the measure of angle J is 90. The measure of angle L is 145. We go 90 minus 145. That equals the absolute value of negative 55, which is 55. So you say the measure of angle JKL is 55 degrees. Bless me. And then we go from JKN. Well, N is at 0, so we don't really need to do any of our subtraction there. This angle will be 90 degrees. And so now we go through and we classify these. LKN, it's greater than 90, but it's less than 180, so this would be an obtuse. JKL, it is greater than 0, but less than 90, so that's a little angle, it's acute. And JKN, that's exactly 90 degrees, that is a right angle. So there you have it. I'd like you now to pause the video and then answer this Godic question number 2. What are the measures of angle LKH, HKN, and MKH? You can use the graphic up above. Alright, and now you can check your answers with mine. LKH 45 and acute, HKN 180 and straight, and MKH 145 and obtuse. Alright, so congruent angles are angles that have the same measure. Remember when we talked about congruent sides? They were sides with congruent lines. They are lines with the same size, same shape, same length. The same type of idea with congruent angles. If we can say that the measures of two angles are the same, that means that those two angles are congruent. We use that fun congruent symbol. So if we start with a drawing and we have angle A and angle B, they both have these congruent arcs in them. The measure of angle A is equal to the measure of angle B, then angle A is congruent to angle B. Remember, you can mark them with arcs to show that they are congruent. If you ever get two angles, if you have a few different angles and maybe you've got one angle here and that's got that mark, and then you've got another one over here with that mark, and then you've got two other angles that are congruent, you're going to give these ones double arcs. And that means that these two would be congruent over here, and that these two over here are congruent. So, now let's do some actual problems with congruent angles. So, here we have some synchronized swimmers. When they are doing their swimming, they're making angles all the time. And so if you look at this, the measure of angle GHJ, that's the one down here. This one is 90 degrees. It's given to us in the problem. So if this is 90 degrees, how much is the angle KLM? That's our angle right here. Well, if you notice, this one's got a JHJ. It has these two arcs in there. KLM also has two arcs, which means that they are congruent. So angle KLM would also be 90 degrees. So what I'd like you to do now is pause the video, answer this got it question down below. And so if we look at those, they each had that one arc, and so the measure of angle DEF is going to be the same as the measure of angle ABC, 49 degrees. Alright, last slide. Here we have one more postulate. It's the angle addition postulate. And so what this is saying is that if you have a point B, which is interior to a larger angle, angle AOC, so we have this point B right here, then the measure of the two angles that makes angle AOC and angle, or AOB, sorry, and angle BOC, those are going to be congruent to the measure of angle AOC. So these two smaller angles are going to equal the bigger angle. And so if we're going to use this postulate, that tells us that, okay, we have this large angle RQT, and that's 155 degrees. And what that means is that that RQT, let me use a different marker, RQT angle, the measure of angle RT is going to be equal to the measures of angle RQS and angle TQS. And so now we can plug in all those values that we know. We know that RQT is 155 degrees. We know that RQS is 4x minus 20. We know that SQT is 3x plus 14. So now if we take the time to combine all our like terms, 4x plus 3x gives me 7x. Negative 20 plus 14 is a negative 6. This equals 155. Add 6 to both sides. You get 161 equals 7. Now we divide both sides by 7 and we get x equals 23. If we plug that in, 4 times 23 minus 20. That gives us 72. We do 3 times 23 plus 14. That's going to give us 83. If we add 83 and 72, we get 155. So we did this correctly. So the measure of angle RQS is 72 degrees, and the measure of angle TQS is 83 degrees. Alright. And so now what I'm going to have you do is do the got it question down here. Pause the video and find the measure of angle DEC and CEF. You can check your work with mine. I got the measure of angle DEC is 142 degrees. The measure of angle CEF is 38 degrees. I took the time to double check them. They both added up to 180 degrees. So there you have it. Alright. Homework. Oh. That your homework for the day. Here's the actual homework for the day, and you guys actually watched me change that. You're going to do 6 through 32 evens. Always double check that this is the same homework I've posted online. I may change it, and if I do, I'll try to make that obvious to you guys. So this is the end of lesson 4 of chapter 1 of